So the first problem that we are going to write is going to be a very simple function that will return the multiplication of a number by 2. So when we write functions in MATLAB, we would start off by typing edit, which will open the editor, followed by the name of the function, multiply by 2. And MATLAB will automatically add .m extension at the end of this file name. If the file does not already exist, it'll ask you whether you would like to create it, and we will say yes. MATLAB opens the editor window where you can type your commands in. You can type any commands that you would normally type in the command window inside this file. When you are writing functions, the first line in the file should have the name function, followed by any output arguments that this function will return. Let's say out, followed by the name of this function without the .m extension, multiply by 2. So the function name should always be the same as the file name. And then you would open parentheses and list the list of arguments that this function should take in. For this example, we have a single variable that we will multiply by 2, and let's call that variable a. Now I can give any other name to these two variables, out and a. I can change them to apples and oranges, but I have to be consistent in the rest of the code if I change the names of these variables. So I want this function to return a multiplied by 2. The return variable will be out, so I need to store a multiplied by 2 inside the variable out by just saying out equals a times 2. When I'm calling this function in MATLAB, I can just type the name of this function in the command window, open parenthesis, and then followed by an argument that will be passed to this function. And this argument can be a simple number, such as 5, or a complex expression that MATLAB will evaluate and reduce it to a single number. So let's say 5 plus 10. So I typed the name of the command incorrectly, and MATLAB gave an error. Let's repeat with the correct name, multiply by 2. And you get this error. Can you guys explain this one? So when this happens, it's usually because you are either missing the first line or because you have not saved your file yet. So let me save my file by clicking on this icon or just hitting Control S. If you are using a Mac, the shortcut keys would be different. I would have no idea what they are. You can look at the menu and see what keyboard shortcuts are. So for Windows, Control S will save the file. Now let's repeat the function call in the command window, and we get the result 30. Now the sequence of events that goes on when you call a function are the following. MATLAB will first evaluate this 5 plus 10, which is 15. And then it will make a function call to multiply by 2. It will provide this input value and copy it into the variable a. Once you are inside this function, you have a box named a that contains whatever value you pass to that function, in this case 15. And then we create another variable called out that will store 2 times a, which is 2 times 15, and that's 30. And then when that line of code is done, this function has done its job. It will return back to the caller, which is the command window. The out variable is returned. Since I am not really storing the value of this output variable in the command window, the value will just be printed out in the command window. And because I am not saving it into any variables, MATLAB will automatically save it in the special variable called ans. If I put semicolon at the end, I will not get any displays, so the output will not be printed, but the value returned by multiply by 2 will still be stored in the variable named ans. So let's clear the ans variable by calling the clear function, and you can watch this ans variable disappear in the workspace, and repeat the multiply by 2 function call, and as you see, the variable appears again in the workspace window. When you are working in the command window, you can hit the up arrow key to retrieve the most recent commands that you have typed. So if I hit up arrow key once, it gets me the most recent one, up arrow key twice, one before that. Now, if you know the prefix of a command that you typed in your history, then you can just start typing the first few letters, let's say CLE, and then when you hit up arrow key, it will only retrieve the commands that start with CLE. So this is a convenient way to sort of retype the commands that you have already typed in the command window. Make sure that your file extension is .m, and you can confirm that by looking at the current folder and checking out the extension of your file. On Windows, there is an option to hide or show the extensions of your files. For most Windows users, this option will be disabled, meaning Windows will not show you the extensions of the files. To enable it, in an Explorer window, you can go to Tools, Folder Options, View, and then scroll down and uncheck Hide Extensions for Known File Types. So that box should be unchecked, and then hit Enter. That way, the extensions of the files will be displayed for you. This is important when you are programming because you want to know whether a file is a text file or a MATLAB file or a Word document. Okay? Even though they may have the same name, they may have different extensions that would normally be hidden from you. Now, instead of returning a single output argument, functions can return multiple output arguments. In this function, we are asked to multiply and add 2 to a given input number. So let's do that. I will again start by typing edit, multiply, and add 2. I like giving names that are all lowercase, and I would highly recommend that you do the same so that your code works both on Windows and other operating systems. I will again start by typing function. Now, instead of returning a single output argument as I did before, I need to return multiple outputs. So let's say A and M, so we can refer to addition and multiplication. And you enclose these in square brackets. So when you have more than one output argument, you enclose them in square brackets and you separate them by commas. After the equal sign will come the name of the function, multiply and add 2, and we will open parentheses and provide the input arguments. In this case, there's only a single input argument. Let's call it x. Now, this function should fill in both A and M. So inside this file, I should have at least one line of code that says A equals something, and at least one line of code that says M equals something. So A, let's say, will be equal to x plus 2, and M will be equal to x times 2. So effectively, I wrote a function that will take an input and return that function, that number plus 2, and also that number multiplied by 2. And I'm getting 2 different output variables from this. When you are calling this function in the command window, you can just type its name, multiply and add 2. Let's provide the number 20. So after I do this, MATLAB will take the number 20, go inside that function, and copy it in the variable x, and then execute the rest of the file line by line. Now, there is a way in MATLAB to sort of track the progress of the execution line by line, and that's called debugging. You can place a blob next to the line number, so there are ticks next to the line numbers. You can click on any one of them. That will make MATLAB stop the execution at that line. And then once the execution is there, you can examine the values inside the variables in the command window. And there's a difference between the command window workspace and the function workspace, meaning they are 2 different rooms. They would have different boxes, and those boxes may have the same names, but they are not identical boxes. They can have different contents. The only way to pass the contents from one room to the other is through input and output variables. So even if you have a variable named A in both rooms, in both workspaces, they would not refer to the same box. All right, let's execute this function, and you can sort of watch the workspace at the bottom. Hit enter. The execution will go into the multiply and add to function, and you can see the green arrow shows the next line that will be executed, and you see the workspace now contains the variable x, and the value 20 was copied into the variable x. I will execute this line. On Windows, you can execute the next line by hitting F10, the function key 10. Or on other systems, you can look at the toolbar and click on the step icon. So step means just execute the next line. So it executed A equals x plus 2. It created a new variable named A and placed x plus 2 in it. So A now contains 22. You can watch the progress of the boxes in the workspace. Let's execute the next line of code once more by hitting F10. And it creates a variable named M that contains x times 2, which is 40. And you can see the shape of the arrow change. This indicates that MATLAB is done with this function and it is time to return from this function. I'm going to hit F10 again, and I'm back in the command window. So now the execution is back in the command window. MATLAB printed ans equals 22. Now the function that I wrote returned 2 output arguments. But if you do not capture these output arguments, meaning if you do not store them into variables, MATLAB will only store the first one. And in this case, it only stores the first one in the ANS variable, and it prints it because I did not put a semicolon at the end. If I put a semicolon at the end, it will still store it in the ANS variable, but not print it. The way to capture output arguments from functions is by assignment. Let's say R equals that. So when you have multiple output arguments, you have the option of capturing any number of them, starting from the first one. So by doing R equals multiply and add 2, I am only capturing the first output argument, which is this A. And the value of R, if you look at the workspace window, will be 22. Or let's just omit the semicolon so we can see the result, 22. To capture more than one output argument, you need to enclose the variables similar to the way that you enclose them in the function definition using square brackets, and the variables should be separated by commas. Let's say R, comma, S equals multiply and add 2, and then the input value is 20. And then the value of A from the function will be stored in the variable R in the command window, and the value of M that's calculated in the function will be stored in the variable S in the command window. All right, so now we will write a function that will take a string. The definition of a string is an array of characters. You can have string values by enclosing them in single quotes. Let's say single quotes A, B, C. So that's an array of 3 characters, and also called a string. So we will write a function that will take any string and return the same string in reverse order. So if we provide our function with ABC, as a result, we want to get CBA. Now, before I start writing the function, let me work in the command window to show you some concepts about characters. Last week, I described that each character maps to a number. Okay, and you can figure out which number it is by converting the character to a double. And the small case letter A maps to the number 97. And it's no surprise that when you do B, you'll get 98. And this is described in a table called ASCII table. So the decimal column maps to a character column, the small letter A maps to the number 97, small letter Z maps to the number 122. You don't need to memorize these numbers. You do not need to memorize which character maps to which number, but you need to be comfortable with converting between the two. When you are converting, you are simply changing the data types of these numbers. Once you have a number, you can convert it back to a character by wrapping it with the character function, and you will get B again. Let's type 98 instead. We get the character B. So there's a difference between the character 1 and the number 1. The number 1, when you convert it to a character, maps to a non-printable character. Number 1 represents start of heading. Number 10, for instance, is a new line character. And it will display a new line, which, again, you are not able to see. When you enclose a number in quotes, you are creating a character value, which is not identical to the number 9. So once we have this ASCII table, we can sort of shift numbers and operate on the alphabet. So if you want to shift a letter by 1, you can just say A plus 1, and you will get the next letter. Let's say A plus 2, you get the value C. Now there's a distinction between a character and the number. Another important distinction is between a string and a variable that has the same name. So when I say A without quotes, I am referring to a box, a variable that contains a value, which could be the character A, but it could also be anything else. So A equals 23.5. The variable A now contains the value 23.5. But when I say single quotes A, I'm referring to a character, which is essentially a number. Okay? So it's not a variable, it's a number. And I can store these values in other variables. Let's say apple equals A. Apple is a variable. A is a string that I'm storing in this variable. Instead of having a single character, I can have a number of characters, A, B, C, D. And that in MATLAB is represented as an array of numbers. So they are consecutive boxes in memory that contain each of these letters. You can add numbers to these, so you can have mathematical operations. I'm shifting A, B, C, D with 1. And MATLAB implicitly converts this character array into a numeric array. As a result, you get 98, 99, and so on. If you want to get a character array as a result, you have to convert it back to a character array by calling the character function and providing that value, and you get BCDE. You can do the same thing by providing an array of numbers, 98, 99, 100, 101. Now let's get back to our problem. It's asking us to write a function that takes a string and return the same string in reverse order. Let's type the function name, edit, let's call it reverse string. This function will take a single argument. Let's call it S. And return a single out argument. Let's call it T. Now there's a function in MATLAB that helps you reverse arrays. It's called fliplr. Let's type DOC to get the documentation for this function. And MATLAB should open the documentation window. You get a description, flip matrix left to right. So it both supports arrays and matrices, but in this example, we will only focus on arrays, which are just a single row matrix. And a description and a basic syntax. In the usages example, if A is this vector, it will return the same vector reversed. So this function can work with numbers, and it can also work with character arrays. Let's try it in the command window. Flip LR 3, 10, 0. And I got 0, 10, 3. If I provide an array of characters, A, B, C, D, E, I get them flipped. Okay? Now, another way to write an array of characters is using the array notation, but separating these strings. And it will still give you the same result. Okay? So let me do this. So I'm sort of concatenating the two strings into a single string. It's no different than providing the entire string as a single value. All right, let's get back to our function. Now we know how to work with the flip LR function. We'll just say t equals flip LR s. The function will take the input variable s, do a flip, and store the result in t, which is returned from this function to wherever this function is called. And we will call it from the command window. Let's remember to save this function. Save. And call reverse string. And then provide apple. And it will reverse the string. Okay? Now, some of you, when you are writing your code, you may do something like this, where you don't put a semicolon at the end of your code, and you run your function, and you still get the same result. Okay? I mean, you see the same result, but it's not really getting the correct answer that we are asking. So what's happening here is that you are calling the reverse string function, providing it a value, which is copied into the variable s. And then inside this function, you are flipping the variable s. Since you did not put a semicolon at the end, MATLAB prints the result. But you have failed to provide a value in the output variable. Okay? And you can see that error because MATLAB underlines it with a red line. The correct way of doing this is to make sure that a value is stored in the output variable. And to avoid these errors, I would recommend to always end your statements with semicolons. So another symptom for this problem would be that if you try to store the result of this function call in a variable, let's say A, MATLAB will give you saying that in that function, the output argument t has never been assigned. All right, in the last problem, we will write a function that takes an integer number, which will be the number of days, and it will return the number of months and years that x has. And for this problem, to keep it simple, we will assume that a month contains 30 days and a year contains 12 months. So if x is number of days, let's say it is 395, your code should work regardless of what value x has. So whatever value x has, your code should still give the correct answer. Let's do this by hand first. How many years do I have in here? 1 year. How many remaining months? We are left with 35. That's 1 month. And then we will have 5 days left. So 1 year, 1 month, 5 days. So it's easier to extract out the largest component first. We will first extract out the number of years from the number of days, and then we will operate on whatever is left. Let's say edit day to months, years. And let's return number of years, number of months, number of days. Days to months, years. And then we will take a single input variable x. So let's start off with figuring out how many years we have in x. To do that, we would just divide x with 360. So if x is 395, the result should be 1. The result of this expression will be a floating point number. It will be 1 point something. We're not really interested in that something. We just want 1 year. When you want that, you need to take the floor of the floating point number. So the floor of 1 point something will just be 1. Let's test this in the command window. 395. And x divided by 360 is 1.09. And let's take the floor of that. It will get rid of all the decimal places and give you the number 1. So we correctly found the number of years from the number of days. So let's store that in a variable called y. Now once you identify the number of years, you can subtract that amount from the total number of days you had. So you want to get rid of the 360 from the 395, so you can work with the remaining 35. Okay? So we will update the variable x. So x contained 395. We will subtract from x y times 360. If x were 395, after this operation, x would become 35. Okay? Once I have removed all the number of years from x, I can now deal with the number of months. And it'll be very similar. I'll just say m equals x divided by 30. That will give me the number of months in x. Again, I'm not interested in the decimal places, so I'll just take the floor of that number. So that will give me the number of months in x. And now I need to remove those days that complete to the number of months from x so that I would have the number of days left. And I could either say x equals x minus m times 30. Since x will be the number of days that I am interested in, instead of storing this value in x, I'll just store it in d. Or the other option you have is do that and then say d equals x. So let's test this in the command window. All right, 395. If you don't capture all the output arguments, only the first one will be returned. In this case, the number of years is returned. Let's capture all of them. Y, comma, m, comma, d equals that. So y equals 1, m equals 1, d equals 5. Let's change this number from 395 to something else. Let's do 63. So that should be 2 months, 0 years, and 3 days. So we get 0, 2, 3. Now the variables in the workspace has nothing to do with the variable names that you have in the function name. I can have a different variable name here. So let's call them y apple, m apple, d apple. And the result is the same except that the variable names are different.